welcome to the Deep Dive. If you're joining us today, you are likely staring down the barrel of your mobile security certification exam.
Which is, definitely a beast of a test.
Oh yeah, for sure. And frankly, this isn't the kind of test you can just cram vocabulary words for and hope to pass. We're dealing with open-ended questions here,
Right.
the kind that require you to write out 2 to 3 sentence answers. You have to prove you actually understand the architecture of these networks, not just the acronyms.
Exactly, which is why we're taking a highly tactical approach today. Think of this as your pre-mission briefing.
I like that.
We have a very specific game plan. We are going to map this discussion directly to your study materials, specifically walking through the mobile security playbook slide by slide in exact order.
And to make sure you can follow along with your deck, I'll be calling out every single slide transition by its number and title.
Perfect. Because we're going to break down the why and the how behind the security concepts so you can articulate them clearly when you're sitting in that exam room.
So grab your playbook and let's get right into it. Let's kick things off with slide 1, Exam Hacker Playbook. Mobile security.
This is our foundation.
Right.
Yeah.
I mean, the whole reason a specific mobile playbook even exists is because we're no longer just protecting desktop computers sitting behind locked doors in corporate offices.
The paradigm has completely shifted.
Yeah, and the defensive strategy has to shift with it.
Right, the perimeter has dissolved. And if we flip over,
Moving to slide 2, the mobile battlefield.
yes, slide 2, we start to see the sheer scale of what we're dealing with here. We are talking about over 5 billion mobile subscribers worldwide.
5 billion.
It's massive. When you have an attack surface that large, smartphones aren't just an afterthought for cybercriminals, they are the ultimate target.
And the threats on this battlefield generally fall into 3 buckets.
Right.
First, you have malicious websites.
Right. And the interesting thing here is how sophisticated the attacks have become. Attackers aren't just throwing generic malicious code at a wall to see what sticks.
No, they deploy code that actively interrogates your device.
Exactly. It figures out exactly what hardware and OS you're running and then serves up an exploit custom built for your specific phone.
Which is terrifying.
Yeah.
Second, you have unsecure apps. Think about your own habits. You probably spend way more time inside individual applications than you do browsing the mobile web.
Oh, absolutely.
But those standalone apps often lack the standardized, robust security frameworks that modern web browsers have spent decades perfecting.
Then there's the third threat, which is just simple physical reality, data loss. These devices hold our entire lives, yet they are small enough to slip out of a pocket on the subway.
So true. But let's look at how attackers actually gather intelligence from these devices. Here is a major quiz radar alert for you.
Pay attention to this one.
On your exam, you're going to see questions about spyware, and it is crucial to understand the mechanism of how it operates. Spyware monitors and logs call history, GPS locations, text messages, emails, and keystrokes.
And here is where test writers love to lay a crap for the short answer section. They'll try to conflate spyware with active exploitation.
Yep, huge distractor alert. You need to explicitly state that spyware does not magically crack weak passwords.
Nor does it root or jailbreak a device. It's a passive tool.
Right.
If you're asked to explain why passive data collection is often more dangerous than an active attack, think about the noise level. If a hacker tries to brute force a password, they trigger lockouts.
They trigger email alerts.
They wake up the IT department.
Exactly. But if they drop a piece of spyware on your device that simply records your keystrokes while you log into your banking app,
They get your password in total silence. The Ninja is often deadlier than the battering ram. That passive observation is the core mechanism of spyware.
that's a great analogy to write out on the test. Let's look at how we defend against that ninja. Next up, slide 3, the 5 pillars of mobile defense.
Designers rely on 5 core architectural concepts to keep these devices secure. The first pillar is access control.
If we use a physical analogy, these are the guards at the front gate.
Exactly. This encompasses your passwords, your two-factor authentication, and crucially, your biometrics. Access control is also responsible for enforcing the principle of least privilege.
Which is the idea that a user or an app should only have the bare minimum access necessary to do its job.
Right.
Oh, and pay close attention to the biometrics piece, guys. If you get a quiz question asking which security model area handles fingerprint scanners or facial recognition, the answer is always access control.
It's just a high-tech guard at the gate.
Yep.
The second pillar is digital signing, which acts like a royal seal on a document. It mathematically proves that an application hasn't been tampered with since the developer published it.
It guarantees it comes from the original author.
Right. Third is encryption, our secret code. This secures data in transit, like a text message flying through the air, and data at rest, which is the stored data sitting on your flash drive.
And remember, for your short answers, mention that encryption can be software-based, which is generally slower because it taxes the main CPU, or hardware-based, utilizing a separate, dedicated chip.
The fourth pillar is isolation.
I always picture this as a moat around a castle.
That's a great way to look at it. In the mobile world, we call this application sandboxing. It forces every single app to run as its own separate, isolated process.
So if you accidentally download a compromised flashlight app, the moat prevents that bad app from marching over and infecting your banking app.
Precisely. And the final pillar is permissions, or the guest pass. Even if an app is in its sandbox, it still has to explicitly request access from the user for sensitive data.
Like asking to use the camera or the microphone.
Exactly. Seeing how these 5 pillars are implemented practically is where things get really interesting.
Which brings us to our next transition. Flipping to slide 4. The Tale of Two Cities. Android versus iOS.
You have 2 dominant operating systems, but their underlying philosophies on how to secure a mobile environment are radically different.
Let's look at Android first. It operates a bit like a massive, bustling, open bazaar. It's an open source platform based on a Linux kernel and maintained by the Android Open Source Project, or AOSP.
And for the exam, lock this fact in right now.
Yes, Android holds the largest share of the smartphone market globally. The test will almost certainly throw distractors at you, suggesting Windows or BlackBerry hold dominant shares.
Do not let those fool you. Android is the prevalent market leader,
Period. Now, on the other side of the fence, you have iOS.
which is much more of a VIP-gated community. iOS is a completely proprietary operating system and runs exclusively on Apple's own hardware.
Because Apple exerts total control over both the physical device and the code, it generally presents a higher baseline of security right out of the box.
The trade-off for that security, however, is opacity. The lower-level workings of iOS are strictly undocumented and closed off to the public.
To really understand how to attack or defend these systems, we have to look under the hood. Let's dig deeper on slide 5. Anatomy of Android. The OS stack.
The easiest way to visualize the Android stack for your short answer questions is to picture a highly secure corporate office building.
Okay, an office building.
And the golden rule of this building is that messages can only pass one floor at a time. No one gets an express elevator from the penthouse to the basement.
Got it.
Down in the basement, you have the device hardware and the kernel. This Linux-based kernel manages the low-level hardware drivers. The code actually turning on the Wi-Fi antenna, the camera, the audio.
One floor up, you have the lobby.
Right, which is the hardware abstraction layer, or the HAL. The HAL is essentially a translator. It takes software requests coming from the upper floors and translates them into hardware actions the basement can understand.
Moving up another floor, we find the specialized workers. This layer houses the native C and C++ libraries, things like WebKit and SuperLite.
Crucially, this is also where the Android runtime, or ART, lives. It provides the Java runtime environment.
It's worth noting that ART compiles applications ahead of time during installation.
Huge performance boost there. Above the specialized workers is middle management, the Android framework. These are all the Java APIs, like the Location Manager or Activity Manager.
Finally, we reach the penthouse. This is where the system apps live. The dialer, your email client, the calendar, basically the end-user apps.
Now, if the exam asks you to explain why this strict floor-by-floor communication makes the system more secure for your short answer responses, rely on that building analogy.
Right. If a malicious game in the penthouse wants to silently turn on your microphone in the basement, it cannot bypass the system.
The request has to pass down through the framework, then the runtime, then the HAL.
And at any one of those floors, the system's security pillars, like permissions and isolation, can intercept the request, realize the game doesn't have a guest pass, and block it.
It's entirely about security through structural isolation. Now let's contrast that with Apple's architecture.
Now for the Apple side, slide 6. Anatomy of iOS, the OS stack. And visual exam alert for everyone listening. You must memorize this specific image for the test.
Yes, test writers love to give you a diagram without a title.
If you see layers labeled Cocoa Touch or Media Layer, you are looking at the iOS OS stack. Don't second guess it.
Let's break down those layers from top to bottom. Up top is the application layer. That's Apple's system apps and third-party apps.
Immediately below that is the Cocoa Touch layer. This is the critical identifier for iOS. It defines the appearance, multitasking, and touch-based input through UIKit.
Below Copo Touch is the media layer, which is the graphics, audio, and video frameworks.
Next down is the core services layer. This is divided into public frameworks like contacts and location, and private frameworks like SMS and phone services.
Finally, at the very bottom is the Core OS layer. This deals with low-level security, networking, and the file system.
And again, distractor alert here, that visual represents the iOS stack, not the mobile security model or Android APIs.
Exactly.
So we have these beautifully engineered architectures. But what happens when the user decides they don't like the rules? Moving to slide 7, breaking the chains. Rooting and jailbreaking.
This is where a user actively works to bypass the manufacturer's security constraints.
It's the equivalent of picking the lock to your own apartment. Yes, you get total freedom to move the furniture, but now the door is broken for thieves too.
Perfect analogy. On Android, this process is called rooting. The why behind it is usually to overclock the CPU, change visual themes, or, crucially, to remove pre-installed manufacturer bloatware using tools like King or Root.
On iOS, bypassing Apple's restrictions is called jailbreaking, and that's done primarily to sideload apps not found in Apple's approved App Store.
Now for the quiz radar. The exam will test your understanding of the consequences of overriding these manufacturer security restrictions.
It's not just voiding the warranty. You are actively disabling the sandboxing modes we discussed, which invites malware infections.
And you need to mention the absolute worst-case scenario.
Bricking the device.
Right, making it impossible to turn on or repair. Just an expensive paperweight.
Understanding how users break their own devices gives us insight into how attackers do it. Let's switch to the offensive on slide 8. The pen test process. Planning the heist.
Whether you are an ethical hacker or a malicious actor, infiltrating a mobile environment follows a 3-step process. Step 1 is footprinting.
Casing the joint.
Exactly. Using network mapper tools like Nmap to locate mobile devices attached to a network and return their OS version and type.
Step 2 is scanning. Finding the alarms. Using tools like Kismet to passively identify the specific wireless networks the devices are looking for.
Step 3 is exploitation, breaking in, using man-in-the-middle attacks, spoofing, and ARP poisoning to exploit the client-side vulnerabilities discovered earlier.
I really want to stress a major test trap here. Do not confuse footprinting with exploitation. Using Nmap to locate devices on the network is purely footprinting.
It's reconnaissance.
Right, it is not an actual exploit.
And the specific ways you break in change depending on the OS.
Drilling down on slide 9, OS-specific pen testing strategies. Let's start with Android.
Android pen testers have a few distinct tactics. They might use the APSet tool to exploit the Android Intense messaging system.
They'll also check for unencrypted passwords and Skype contacts left plain in the SQUITE database.
But the big focus for your short answer prep should be the browser attack.
Yes, the quiz radar here is investigating vulnerabilities in the Android browser. Hackers check for a cross-application scripting error.
By using infected JavaScript code, they can break down the browser's sandbox and gain broader access.
If we look at iOS strategies, Apple tactics contrast pretty sharply.
Very different. A pen tester might attempt jailbreaking with tools like Cydia or Answang.
Or they'll try physical workarounds, like bypassing the password code security using a smart cover manipulation.
Right, holding the power button while closing and opening the cover to glitch the OS.
They also intercept wireless parameters to perform SSL stripping attacks.
So with all these attacks, how do we protect the users?
Let's play defense on slide 10, defending the user. Digital street smarts. The exam loves testing practical application here.
Exam Trap 1 involves social media privacy. The golden rule is, don't auto-upload photos to social networks.
And you need to be able to explain why. Because photos contain geotags that track a user's physical movements.
Passcodes and routing have absolutely nothing to do with geotags. If the options try to trick you, stick to geotags.
Exam Trap 2 is the lost device scenario. Say a doctor loses a phone full of sensitive patient data. What is the best prevention against unauthorized access?
The correct answers are configuring the device to remotely wipe as soon as it is reported lost, or wiping after a number of failed login attempts.
Distractor alert on this one. Installing a locator app or updating the OS won't protect the data once the phone is already in enemy hands.
I want you to explain in 2 to 3 sentences why reactive measures fail compared to proactive remote wiping. Tracking a phone on a map does nothing to protect the data sitting on it right now.
A proactive remote wipe guarantees the info is incinerated before the thief can even try to break in. But relying on individual users for that isn't scalable. Moving to enterprise control with slide 11. Managing the chaos, MDM software.
MDM, or Mobile Device Management, is deployed as a combination of an on-device application or agent that communicates with a backend server.
It receives policies, enforces passcodes, performs remote wipes, and monitors inventory.
Here's your quiz radar for this section, the jailbreak flag. If an ethical hacker roots or jailbreaks a mobile device, how does the MDM react?
The answer is that the MDM inventory will flag and show the device as vulnerable.
But here is the trap. It does not automatically lock the user out or erase passwords.
No, it just updates the inventory to reflect the vulnerability.
And that corporate control gets complicated when we talk about personal phones.
Let's talk about using your own gear on slide 12, the BYOD Balancing Act.
Bring your own device is like using your personal car to deliver top-secret corporate briefcases. Because of that, BYOD networks are strictly governed by the organization's acceptable use policy.
Not a cloud usage policy, not a remote management policy, the acceptable use policy. And here is the ultimate BYOD risk you need to know for the exam, mixing personal and corporate data.
It is a double-edged sword.
Yes. On the exam, state that this is a security issue for the organization and a privacy issue for the user.
Data exposure only hurts the company, but mixing data hurts both parties. If they wipe the phone to save corporate secrets, your personal photos are gone too.
We're almost at the finish line. Slide 13, decode the test. Common exam distractors. Let's do some rapid-fire trap avoidance.
First, spyware versus weak passwords. Spyware logs your data, like GPS and texts. It does not magically crack weak passwords.
Second, AUP versus cloud policy. BYOD is governed by the acceptable use policy, the AUP, not a cloud policy.
Third, sideloading versus rooting. Sideloading is just the act of installing unapproved apps. Rooting is the actual exploit used to gain admin privileges to remove bloatware.
Fourth, footprinting versus exploitation. Using Nmap is footprinting, it's reconnaissance. Using man-in-the-middle is exploitation, the actual attack.
Excellent.
And finally, slide 14, Final Boss cheat sheet, parts 1 and 2. Let's lock in the absolute truths.
Okay, running through the ultimate FAPs to memorize. Malicious websites use code specifically designed for target mobile devices.
Access control handles passwords, biometrics, and 2FA.
Android has the prevalent market share.
If you see Cocoa Touch, it's the iOS stack image.
Rooting is the only way to remove manufacturer bloatware on Android.
Device bricking is the worst-case consequence of rooting or jailbreaking.
Geotags are the reason you never auto-upload photos.
Remote wipe is the absolute best defense for a lost device holding sensitive data.
Footprinting uses Nmap to locate devices.
Cross-application scripting is the JavaScript error used to break the Android browser sandbox.
MDM architecture is an on-device agent communicating with a back-end server.
MDM inventory shows rooted devices as vulnerable, but doesn't auto-lock them.
And finally, BYOD mixing data causes security issues for the company and privacy issues for the user.
If you can write out the underlying logic connecting those concepts, you're going to dominate this certification. Congratulations on making it through the playbook and prepping your brain for those higher-level, short-answer questions.
You're in great shape, but before we sign off, I want to leave you with a final, somewhat provocative thought to mull over.
Let's hear it.
We've talked extensively about how isolation, sandboxing, and strict stack architecture protect our devices from rogue apps. But as our mobile devices become more deeply integrated with AI assistants, those assistants require cross-application context to function.
Right, like an AI reading your email to update your calendar and check your maps.
Exactly. So how will the fundamental pillar of isolation have to evolve? If the AI needs a master key to everything, are we essentially building the ultimate unpatchable vulnerability into the penthouse of our OS stack?
That is a brilliant question, something definitely worth thinking about as this technology evolves. Good luck on your exam, trust your preparation, and keep exploring.